Okay, here we are at site 7 on the Anity Burn, and as you can see, the river has become very shallow and wide. Now we're about 250-300 meters from site 6, and there's been some really substantial changes both in geology as well as some human interference on the river, which has had a pretty dramatic effect on its discharge. So before we have a little look at the factors that are likely to affect your data at this site, let's consider what we are expecting at site 7. Now, first of all, we would be expecting the discharge to have increased from site 6. However, as you can see in what's in front of you, as well as in your own data, it's likely that the discharge has dropped substantially from site 6. And the reason for that is going to be explored later on in this tutorial. In terms of the bed load shape, we would expect rocks to continue to become smoother than from the previous site with less angular boulders. And that's probably going to be the case when we explore the river further closer to the river. And that's got something to do with the fact that there's been a geological change. The boulder size is expected to continue to get smaller from the previous site. We'll explore whether that is likely to have happened or not in your data. And finally, the efficiency of the river channel, we would be expecting the river to be more efficient. However, we might find that actually the river is less efficient than it was at the previous site. And that's got something to do with the geology, as we can see in front of us. So in order to explore the discharge of the river and why it's likely to have changed so dramatically, we need to work our way about 100 meters upstream and explore something that has happened and that has led to a big drop in the amount of water in the river between site 6 and this site at site 7. Okay, I've moved upstream about 100 meters from site 7 in order to try to explain the likely large drop in discharge that you're seeing. Now, this is very unusual for a river for its discharge to drop substantially, so there must be something happening, either natural or man-made, that could cause the river to have a lot less water than it had only a few hundred meters further upstream. In this case, it's because water is being drawn away from the river to fill a pond, and I'll explain to you exactly what is happening. There's been a small weir built across the river that you can see there, and what that's led to on the right hand side, or the upstream side, is a much deeper pool. Now we can see at this point there's an awful lot of water in the river. So at this stage in the river we can see there's, compared to site 6, the river has got a lot more water than it did. I would actually get quite wet if I was to try to walk across that, because it's quite deep and it's also quite wide. But when we actually think about what we were seeing in the first part of this video, just 200 meters from here downstream, the river's much shallower. And if we look after the little weir or dam that's been built, we can see only some water pouring over the top. So where's the rest of the water going? Well, just behind this bush there is a pipe that we can see just there, and water is flowing into that pipe, and we can follow that pipe. It goes under the path. We can't see it obviously, but it is running under my feet where I'm walking, and that water, probably close to half of the water in the river, is draining through that pipe underground, and it's filling a duck pond, which has been built just as a kind of feature to allow ducks to come and nest in this area. So if we go down here we are, this is the other side of the pipe. The water comes out here that we can just sort of see. If I just lean over, it's coming out of the bottom and it's flowing into this rather large duck pond, which I will just walk around the edge of so you can see. It's got a lot of water. Now this is having a substantial effect on our river's discharge, because the water that would be in the river is being drained away to fill this duck pond. So here we are, we get a better view of the duck pond from here, which has a huge amount of water in it, all of which is being fed by the Anity Burn. So when we go back to our main river, which is just across here, and we have a look at site 7, which is the one we're about to talk about, there is only a lot less water here, because if we just look upstream, just under the bridge up there was where I was a second ago, at that pool where there's a lot more water, but it's getting drained off underground to fill the duck pond over there. So at this stage, there's a lot less water, and you can see there's a lot less water. And that is the primary reason for the discharge being a lot lower. So what about the other two factors, the other three variables? What's going on? Well, whilst I'm up on the bridge, I'll be able to talk about efficiency. Why is the river likely to be less efficient than it was at the previous site? Why is its hydraulic radius not going to be increasing? Because that is what we'd expect, an increased hydraulic radius or increased efficiency. And the reason is partly to do with geology, the fact that we are on a soft sandstone rock here, and you can see the flat sandstone rocks either side of the river, are allowing this river to erode down, but it's also eroding quite a wide channel here, which is allowing the water to become very, the river to be very spread out. It has a very wide width, but as a consequence, it's got a very shallow depth. And those two factors means that a lot of the water is coming into contact with either the sides or the bottom because it's very shallow and wide. On top of the fact that the discharge has dropped so dramatically because of the duck pond, if there's less water in the river, then the river's going to become less efficient because more of the water's in contact with its bank and beds. So the drop in discharge is a big reason why there's been a drop in efficiency, because less water lowers the velocity and causes the efficiency to drop, but also because of the geology. Now, if we just walk around to consider the final two factors, rock size and rock shape. So what should be happening? Now, if we think back to when our geology changed upstream at site 3 and 4, when we went to a soft sandstone then, we were finding our rocks getting much smaller and smoother suddenly. And that is certainly what we would expect to be happening here. So here is our sandstone. Now, in terms of rock shape, we can see lots of smoothed rocks in the river channel. If you do see a number of angular boulders, it's likely that any angular boulders are not because they're moving in the river. It's actually because of the steep riverbanks. They're just rocks breaking off, recently eroded because of root wedging or freeze thaw, and they're rolling into the river channel. And what that means is you can see that our river does have a number of larger rocks in it here, but these are not native to the actual river channel. They've just rolled down the steep slopes. So that is why, in terms of rock shape, you're getting possibly some angular, but there are also, if we have a look closely, some very smooth rocks starting to appear. In terms of rock size, you're going to have a mixture of large and very small. We can see some very small grains of sand there in the river, along with some much larger boulders. The smaller rocks are because there's high levels of attrition at this point. Rocks have been worn down to a very small size, and also because the rocks are all sandstone, or most of them are, they're getting worn away very quickly because sandstone is a soft rock. And that explains why they're going to be both smooth and why they are also very rounded and small in size. However, you are also going to get still some larger boulders, bearing in mind that these are boulders coming off the riverbanks, having dropped into the river recently. So it's a mixed site where geology plays a significant factor. You might, when you look at your results, reflect on the fact we have a very steep gradient of the river here. And gradient will be one of the factors, bits of data you will have gathered. And because of the steeper gradient, that would affect the flow of water, the velocity of the river channel. And if the water is indeed flowing faster, then it would be leading to higher rates of erosion of the material in the river, which would mean you'd be expecting possibly smaller than average rocks and rounded rocks. But remember, only when you're writing up your results and you're trying to explain why your results are doing what they're doing, make sure you have a look at your data, see whether things have increased or decreased from the previous site before you offer your analysis.